Hello students, welcome back. We went through some derivative computation using the power rule. Now let's discuss how to deal with exponential and logarithmic functions. Natural exponential functions stay the same even if we take the derivative. Logarithmic function becomes 1 over x. The natural logarithmic function becomes 1 over x. Is there a good problem here? Okay, here we go. Here's a nice problem. Find the derivative function of the given function. All right, let's go ahead and do that. Let's analyze this problem. E to the x power. This is an exponential function. No problem there. And then next we have x to the e power. That's a power function. And then ex, and that too is a power function. Just one power, see? And x over e, that looks like fraction, but as a matter of fact, that too is a power function. 1 over e times x. Again, this is one power. Now e over x, what is it? E times x to the what power? Negative 1 power. Finally, e to the e power. Well, that's actually constant. Therefore, if I take the derivative, let's see, exponential function always stays the same, right? So I'll write e to the x, oops. Now, what's the derivative of this? Power comes out, and x to the, now subtract 1 from the power, e minus 1 power. Does it make sense? Power rule here. Now this too is a power rule. 1e times x to the 0 power, but of course nobody writes like this. Just e. And how about this? Again, multiply by 1 and subtract 1 from the power, so we have x to the 0 power. So we get this. And finally, how about this? Multiply by the power, so we end up with negative e and x to the subtract 1 from the power. What do you get? Negative second power. And then take the derivative. Well, derivative of a constant, so that's 0. And nobody writes like this. Throw that away. And there you go. Do you need to simplify? No, please don't. Do not simplify. Leave it as is so that I can see which term came from where. If you mix up the order, then even if you have correct answer, you're losing the justification. So don't do that. If you just mix up the order without proper explanation, where all those derivative rules are being used, then I'll assume that you just copied from the calculator, you see. There are many symbolic calculation tools that'll just spit out the answer without any explanation, and you don't learn anything that way, and you do not demonstrate your knowledge that way either. By the way, here's the answer key if you're interested. And then warning. See, do not change the order or simplify. Okay, how about the next problem here? We have a bunch of logarithmic functions, so we're gonna get a fraction. So, oops. I just clicked the wrong key. So f prime of y will be, what is it? So we get 1 over y, and then 1 over y squared, 1 over, oops, 1 over y cubed. Is that it? Wrong. If you have just log of x, then we have 1 over x. But log of x squared, that's a different story. You have to do some further manipulation. This is okay, which I just highlighted in blue, but these two are not okay. They're wrong. How do you make it right? Well, there are many different ways to do that, but the easiest way at this moment is to use some log rule. So 2 comes out, and then 3 comes out if you use the log rule. So everything simplifies into 6 times log of x, log of y, excuse me. In this case, the character is y. And then upon taking the derivative rule for the logarithmic function, you get 6 over y. Okay, we went through some elementary differentiation problems. Now, do we have some... All right, we have a little bit more challenging problems here, and yeah, I guess we have enough time. Okay, we're going to do some of these. How to find the derivative of this? Well, it is tempting to do this. Take the derivative of this, then you're going to get 0 plus 1. And take the derivative of this, derivative of 2 is 0. And the derivative of negative 3t, so that's negative 3. And derivative of this 2t squared minus 4t. Looks like this is the answer if you take the derivative of this times derivative of that, but that's wrong. There's something called the product rule that we're going to have to discuss next time. It turns out that derivative of product is not the product of the derivative. Derivative of sum is sum of the derivative, yes, but not the product. In that case, how do you work it out? Well, fold it first. Break it up first. First, and then the next multiplication, and then the next multiplication, and then t times 2, t times 3t, t times 2t squared. And then a bit of simplification here, taking the like terms together. And then you can take the derivatives, one term at a time. 3 comes out, so negative 6t squared. 2 comes out, 10t to the first power. And then this is 1 times t to the 0 power. And constant is gone, like this. Use same idea to calculate this one. Break up the parentheses first, and then you can take the derivative one term at a time. How do you do that? And then you can fold it out, right? Good luck. And once you get that, take the like terms together and everything. Then you can take the derivative. Do not mix up the simplification and the derivative. If you begin to mix those up, then some of the derivatives may be doubly derivative, and you're going to get a mess. Don't do that. Simplify everything, get to the bottom of it, and then apply the derivative rule. Only once. Here's the answer key. Break it up. Here I use completely square formula instead of finding out, but in the end we get the same thing. And then we take the derivative. Multiply the power, subtract 1. Multiply the power, subtract 1. Multiply the power, subtract 1, like that. Okay, still another problem. All right. Even more challenging. How do you handle that? Well, it is quite tempting to do it this way. So take the derivative of the numerator. Maybe bigger font will help. So 6x squared, and then again multiply 6x, and then this is going to be just 1, and then minus 4, that's constant, that goes away, and the denominator, like this. Did I do this right? No. You just earned automatic 0 credit. What did I do? I took the derivative of the numerator over the derivative of the denominator. It doesn't work like this. Previously, we had a product. You could not take derivative of the first times the derivative of the second and multiply them together. That's wrong. Same thing goes here. You can't do it this way. So how do you do it right? Well, there are multiple ways to do it, but my favorite way is to separate the numerators. Like this, separate out all those numerators. Yes, I can do that because the addition in the numerator I can separate. If I have addition in denominator, I can't. And then simplify each. We have x, and then 3/2 x. No, this is x squared, excuse me. Cubic divided by 1 power. And then this one is going to be just 1/2. And then minus 2x to the negative first power. Yeah, we have x in denominator, so negative first power. And then we can apply the derivative rule. Make sense? Well, here's the answer key. Separate all those numerators, simplify, and then you can apply the derivative rule. How about the next problem? The same type of problem, just more complicated. This entire problem can be rewritten in the following fashion. Let's see, a little bit bigger font again. And this is z to the 3/2 power, and this one is z to the 1/2 power, isn't it? So you can separate like this. Minus 1 over 2z to the 1/2 power plus 4z to the 3/2 power over 2z to the 1/2 power. Did I do this right? And then how do I combine all those? The number part is 1/2, z to the second power minus 1/2. So we get 3/2 power. 1/2 z to the what power this time? Power is in denominator, so it's negative power. And then 2z to the, now what power? 3/2 minus 1/2. So this is what? Second power? No, first power. So just see. The number part is 1 over 2, 1 over 2, and 4 over 2. That's why we get all those. And taking the derivative of each, you're going to get this answer. Make sense?